learn about the assembly language first. I think it will talk about 2 sessions lah for this assembly language. I mean, just for this lecture at, because now we are just proceeding to the lecture at, because assembly language, it will be used to, you will use assembly language in your task 2 assignment. So that's why we are urged to teach about assembly language first. And then before we start, you guys watch this video first lah. Okay?
Okay, Miss.
Okay, sambil rehat-rehat, you guys watch that first.
Time. Is learning assembly language in 2020 a complete waste of time? Hey everybody, welcome back. Students love to complain about their classes and their professors and all the things their professors make them do. But if you ever come across a group of angry students who are shaking their fists and their pitchforks in the air and angrily raging against the machine, there's a pretty good chance that they're complaining about assembly language and the fact that their program or their professor is making them learn it. But Dr. Sorber, nobody programs in assembly language anymore. That's not true, but it feels true. There isn't a lot of assembly language programming professionally done out there. There are a few places where you will use it, but a lot of your computing programs are still going to insist that you learn it, at least a little bit. So are they out of their minds? Are they out of touch? Nope. Well, some of them might be. Yours might be. But the point is there are a few good reasons to learn assembly language in 2020. The main reason is the same reason that we get under the hood in the first place. It's the same reason why programming students learn computer architecture, and it's not because we fiddle around with ALUs and Tomasulo's algorithm all day. It's because understanding how computers work under the hood helps improve our awareness and helps us make better decisions as software developers. It helps us understand why some things are slower than others, and that just translates into better decision making and fewer code rewrites. And of course, even though I don't use assembly language every day of my life, there are times where it definitely comes in handy. But first of all, some of you may be wondering, what is assembly? So simply put, assembly is human-readable machine language. It looks something like this, and it's the intermediate language that your C compiler probably uses when compiling your C code. Basically, it takes your C code, compiles it to assembly instructions, and then the assembler converts the assembly code to binary machine instructions that your computer understands. Quick side note, the first assembly language was created by Kathleen Booth back in 1947, who also interestingly was one of the first people to do research into neural networks, way back in the early days when people were first just messing around with computational neural networks. I mean, can you imagine trying to do machine learning at a time when they didn't even really have programming languages? At least not in the sense that you and I usually think of them. It kind of puts things in perspective, so no more complaining about how function pointers are confusing, okay? Now, if you want to see this process up close, what you can do is you can take a C program, here I'm just using Hello World, and compile it with -s, that's capital S, and the compiler will compile your code to assembly. So now we have a .s file that has our assembly code in it, and this can also come in handy when you're trying to make sense out of some mysterious program behavior, or maybe you're just trying to understand a program that you don't have the source code for legal purposes, of course. And of course, any embedded system developers out there know that you're often working with processors and programming tools that are brand new, sometimes not as well tested as the ones that we have on our desktops and our laptops. And we occasionally come across bugs or less than documented compiler quirks. And sometimes the only way to figure out what's going on is to actually look at the machine code that's being generated. Also, another justification for learning machine code is that sometimes you have code that has to be blazing fast. For some reason, every cycle counts, and this little piece of code really, really matters. It has to be super fast. And in that case, although that doesn't happen very often for me these days, but in that case, you may want to write some handcrafted assembly that just handles this really, really fast. But okay, seriously, how much of this do I really need? How much assembly do I need to learn? And of course, the reality is you don't need any of it. Many people have had successful software development careers without knowing any machine language. But how much do I recommend? I recommend that you at least get to the point where you can write some simple programs in assembly. This includes basic arithmetic, I/O, system calls, function calls. You can use assembly as a way to better understand how function calls actually work in C. The call stack is never going to look the same again after you've actually managed it in an assembly program. I also recommend that you try to understand the basic types of assembly instructions. So this includes your arithmetic operations like add, subtract, multiply, and divide, as well as your bitwise operations and or not, XOR. Let's also throw in comparison operations here, greater than, less than, and equivalence testing. Second, we have our memory access instructions. These are our loads and stores. This is how your program gets information to and from memory. Third, we have our control flow instructions. This is like branches and jumps. And some assembly languages also have built-in instruction support for call stack operations, push and pop, and function calls and system calls. Also through this, you're going to want to understand the different addressing modes, registers, direct addressing, indirect addressing. Now at this point, why am I breaking this down into categories? Why don't I just go into some real specifics for what assembly language looks like? And the reason is that the assembly language that you learn really depends on the processor you're using. Every processor has a different set of instructions, and so you're going to have a different assembly language for each processor. And that's one of the reasons why I actually don't recommend that you spend too much time worrying about becoming an expert software developer in assembly, unless of course you want or have one of those jobs where you need assembly every day. In that case, become an expert in your flavor of assembly language. But for most of you out there, the point is not to master a particular assembly language. The point is to understand how assembly languages work and how they convert your C code or whatever code you write in a higher level language into low-level machine code, because that's what's going to make you a better programmer. So if you have a computer organization class or a computer architecture class that has an assembly component to it, great. Stick with that. That's probably all you need. Just make sure you learn what you can from it because it's going to help you in the future. If you don't have a class to help you, of course you can find a book. The other thing is you can use your C compiler to try to learn it. Just write really simple C programs, convert them to assembly, and actually look at how different things in C translate into assembly instructions. Then of course you can look up the documentation for your processor's assembly language and make sure that these translations all make sense to you. One thing to
Oh,
keep in
not
mind
yet.
while you're
Okay.
doing this is make sure that you turn off optimizations, because leaving optimizations on could drive you absolutely crazy, because the optimizer is going to change the code to make it faster in ways that may not seem naturally the same to you. So let me know in the comments below if there's more interest out there for assembly related content. Subscribe to the channel so you don't miss my next video on how you can become a better programmer and have a stronger foundation by getting under the
Okay.
Okay. So why we learn assembly language? What you can say about that previous video, Kelvin? What you can extract from that video just now,
Who? Me?
Kelvin?
Oh,
Yes, Kelvin. Where are you? It's okay lah, Noel lah, Noel.
oh. Um, I learned that if learn the assembly language, we can be a better programmer. Oh, yeah.
Yes, yes, correct. Farah?
From based on the video, um, it helps to it helps us to be not I it helps us to enhance our like coding like that.
understanding on the coding.
Yeah. Like that. Yeah.
Okay, so yes, both of you um, have answered it correctly lah. Okay, so we learn assembly language. It doesn't matter. I mean, it like the speaker said just now. It says that it doesn't really matter to us to really learn in deep the assembly language. It is enough if we understand the basic of the assembly language, unless you want to be an expert in the assembly language lah. Okay, so most of the person that created C sharp, the programming language lah, for example, C sharp, Visual Basic, PHP, the person that create that programming language is the person that are expert in assembly language, meaning they can make the assembly language, they can create another higher level programming language based on assembly language. So if you want to be one of the programming language creator, maybe you have your own programming language later, then you can pursue your study in learning assembly language in deep lah. But if it is not your concern, then you can. It is enough for us to understand it. Just understand it lah. Okay, so in this lecture, I have found a website that containing the tutorial about the assembly language. You guys can see later. Oh yeah, this is it. Okay, so this is there's example in this how to create a variable, constant, arithmetic, but you refer to this letter lah. Okay, so now we will learn about the basic of the assembly language. Astaghfirullahaladzim. I haven't shared my screen. Yes, I am presenting. Thank you, Noel. Okay, can you guys see my screen?
Yeah.
Okay, so this is where I copy. Where I put the tutorial link, and then this is the YouTube link just now, the YouTube URL. So I will update later our this lecture app in our GC Google Classroom. Okay, so in this chapter, before that, I want to ask you guys, what programming language have you learned previously besides the visual programming? The visual programming is the Visual Basic, right?
Yeah.
Okay, so other than that, what else? PHP? Did you learn PHP? C plus?
Only HTML.
Oh,
C++,
HTML.
HTML, C++.
Oh, okay. C plus plus. Okay, wait. C plus plus. When did you learn the C plus plus?
First sem.
Oh, first sem of degree, of this degree lah, right?
Yeah.
Ah, okay, so this is the overview of this chapter. So first we will learn about representing the integer constant, the expression, real number constant, character constant, string constant in assembly. This constants is like how you declare a variable in coding or in visual basic. It is more or less similar to dim. You guys know about dim, right? You are learning programming language, visual basic, right?
Oh
Yeah.
yeah.
Yeah, so dim too is how we so in this topic we are learning how we declare all of that constant. And then we will learn about how to formulate assembly language instruction using valid syntax. So we will learn a basic syntax for the assembly language. And then after that, we will learn about how to create variable using all standard assembly language data types. After that, baru we learn about the defining symbolic constant. But I think we will cover this on next week lah, define symbolic constant. Only these four topic first for this session. Okay, so this is few of the reason that why we need to using assembly language lah. So the first reason is for the educational reason, because you all need to understand how CPU and compiler works. And then when you have better understanding, I mean, it is for you to have a better understanding to efficiency issues of various construct. Then after that, if you are the reason why people want to using assembly language is for them to develop a compiler, a debugger, and other development tools. Okay, so for example, the Visual Studio that we learn all of the way in this. I mean, you all also use the Visual Studio for another language, can? So the developer of that Visual Studio is someone that expert in assembly language. So if you want to develop um, another compiler or debugger or development tools, you need to learn assembly language first. Because when you want to compile any language that or any code, you need to know each of the code what it is in assembly language. After that, it is for the hardware drivers and the system code. If you develop a driver for a hardware, so you need to also learn about assembly language. And then, if you want to develop embedded system is the small system that is attached to a large system. And then, if you want to developing a libraries, so I you know what library, right? What do you understand about library?
Extension.
Extension. Can you remember one of the library from from Visual Basic?
Uh, like no library.
Math.h.
Pardon? Like what?
Math.h.
I cannot hear you clearly.
Math.h kong.
Can you type it? Because I left Visual Studio a long time ago, so that's why I can't remember. Yes, Math.h, yes. Okay, so this is what this if you want to develop a library for any language that you favor, then you also need to learn assembly language. And then assembly language also need to be learned if you for the purpose of accessing instruction that are not available through high level language. So remember, high level language is all of the programming language that we have learned previously, like C Sharp, C++, Visual Basic. Okay, so and other than that, it is for optimizing for speed or space. Okay, so if you learn assembly language, you will know better on how to make your code speed faster or run faster, or you can know how to make your system in only using small space lah. Okay, so this is the example from the C++ code, and then how it is turned into assembly language. And then after that is assembly language will turn all of this to the machine language. So this is the process lah. All of the programming language that you write or you code, it will first will be turned into assembly language. After that, barulah assembly language will convert it to the machine language. So it is the second level of a high level language lah. So we will learn about the hierarchy that this one. Okay, so all of the programming language that we have learned previously, it is in higher level language. After that, assembly language. All of these higher language, I mean high level language will be turned into assembly language. After that, assembly language will turn it into operating system. Operating system will turn it into instruction set architecture. After that, it will be turned into, or not turn, turn lah, or convert. After that, it will be converted to microarchitecture. After that, baru the last language is the language that is understood by the hardware in our computer, which is digital logic. Okay, so for the high level language, it is in level 5. It is application oriented language. And then the high level language will be compiled or converted during the compilation kan. It is the process of converted the high level language into assembly language. So it is the process lah when you are compiling your code. Okay, so this is the code in C++, like example of high level language, which is in C++. Okay, so after that, the assembly language, it is in level 4. So it is instruction mnemonics that have a one-to-one correspond to the machine language. The instruction mnemonics ni is referring to this. Instruction mnemonic is like the pattern of a words or a letter, and then all of this, it has its own pattern, and then it has its own, or it has one-to-one correspondence to the machine language. So this is already predetermined in the system, our CPU, that if you write MOV, it will refer to the predetermined definition inside the machine language. Okay, so the call function written at the operating system level. Okay, so which is in level 3. Meaning to say that you will have later a library. Your library is already predetermined in our operating system. Usually it is in Windows. Okay, so in Windows you already have a library that consisting all of the functions that can be understanding by our operating system. So you just need to check the list of the functions from the operating system to be used. Okay, so when you call when you call the functions, the function that you call is actually in operating system level, which is in level 3. We will not go into deep into the operating system level lah, because it is too deep already. Okay, so the program are translated into machine language, which is level 2. Okay, so this level 4 will call the function from operating or the language from level 3, and then your program will be converted into machine language, which is in level 2. So this is the example of our assembly language. After that, the operating system, this is in level 3. Okay, so it provides service. Like I said just now, there's what a library inside our operating system. For example, in Windows, it is already a lot of service or function that you can use. It is like a library from the operating system. So it is already predetermined in our operating system. Okay, so it after this level 3 will be translated or converted to the level 2, which is architecture level. Okay, so for the instructions at architecture level, so it is in level 2, and also it is known as conventional machine language, and then it is executed by level 1 program. Okay, so this will be executed by the level 1 program, which is microarchitecture. So this is the level 1. So this is how our level 1 looks like. So this level 1 will interpret the conventional machine instruction, which is from the level 2. And then this is executed by the digital hardware, which is in level 0. So this is the level 0 is something like this lah. It is all the hardware, all the transistor. This is our digital logic. So this is what is our machine understand how it is in hardware. Okay, so this digital logic is level 0. It is used by CPU, and then it is constructed from digital logic gates. Digital logic gates is all of this circuit. Okay, so it is also used by system bus and memory. Okay, so after that, we will learn about the data representations. So computer is a construction of digital circuit with two steps, which is on and off. Okay, we already know about this. Okay, so you need to have the ability to translate between different representation to examine the content of the machine. Okay, so this is what we have learned in data representation previously, how to convert all of the video, image, lah, and unsigned binary. Okay, so that is why you learned about that previously. And then the common number system is the binary, octal, decimal, and hexadecimal. So we have already learned about this, about this data representations. Okay, so this is how the assembly language program, the basic of the assembly language program. Okay, so this is how it is looks like. This is actually this is only the screenshot of the function or one function inside assembly language. If you see here, PROC is stand for procedure. Okay, so if we want to find the similarity between this procedure with the higher level language, it is like macam a function. When you declare a function, in your what higher level language, so procedure is kind of similar to the function when you are creating a function lah. Okay, so we will learn about each of the syntax, and then the reserved word, how we will write in assembly language lah after this. Okay, so we will learn about basic element of assembly language. Okay, first, when you want to declare an integer constants, you have to follow this syntax. Okay, so um, whatever in the bracket is optional, meaning you don't need to follow lah. It is not compulsory. Okay, so it is optional for you to put the sign of the digit or the integer. Sorry, not the digit lah, the integer. But usually if it is positive, then we don't need to put the positive lah. Only when it is negative, we will put its this negative sign. And then it is compulsory to have your integer lah. After that, the radix. Radix is, for example, B for binary, H for hexadecimal, D for decimal. Okay, and it is optional to put lah. But if you didn't put, it will assume that your integer is in decimal. So if you want to declare a digit that is in the other type of data or type of radix, then it is compulsory for you to put lah. Okay, so Microsoft syntax notation is used throughout this chapter. Okay, so we are using syntax from Microsoft. Okay, so like I said just now, the element inside the bracket are optional. Okay, so elements within this square bracket require a choice of enclosed element. Okay, so elements in italic denote item which have non-definitions or description, but we don't have italic here lah. Okay, so just focus on these two saja. Okay, so we proceed. Okay, so it is optional to put plus sign or negative sign. Okay, so you can use integer constant punya syntax in declaring binary, decimal, hexadecimal, or octadigit. Okay, so the common radix character that is usually used by assembly language is H for hexadecimal, D for decimal, B for binary, and R for encoded real number. Okay, so this is the example lah. This is 30 decimal, 6A hexadecimal, or this one is 42 decimal. If you didn't put any radix here, then it is 42. And then this is binary, 1101 binary. So whenever you are declaring a hexadecimal, and then your hexadecimal is started with a letter, so you must add 0 at in front of the letter. Okay, so you have to put, if you want to declare a A5H hexadecimal, you need to put 0 in front of it. Okay, so it is if you didn't put, then it will cause error lah. Okay, so if no radix is given, the integer constant is assumed to be decimal. Okay, so this is how to declare the real number constant. So this is the syntax. The real number constant is the constant that has the exponent. Okay, so I remember we have not fully covered real number in our previous lecture, so we will come back to that later. Okay, so this is the syntax lah. First, the sign of the integer, and then it is optional because it is in square bracket ni. Okay, so the sign is optional. After that, you will need this dot. After that, integer, and then the exponent, and then your sign of the exponent, and then the sign of the power of that exponent, and then lastly the power of that exponent lah. So this is the example of how you can declare a real number constant used in assembly language. Okay, so after that, the character. So this character, I think it is similar with most of the higher level programming language. So when you want to declare a character, you only need to put either single quote or double quote. Okay, so this character will be representing or will be stored in 1 byte location in memory. So 1 byte equal to 8 bit. So that string constant. So, and this is also similar with the with the higher level language. So you need to put it in single quote or double quote. Okay, so each character occupy a single byte, meaning each of these will has it at the 1 byte, 1 byte. Okay, so this one also 1 byte, 1 byte, 1 byte. So there will be 6 byte if we store this in memory. Okay, so embedded codes. Okay. So this one, if you want to put a quote inside your string, you need to do it like this lah. Your quote need to be in double quote, and then your string, all of your string should be inside that single quote. Okay.
Okay.
Okay. Okay. So for the reserved word. So reserved word have special meaning in MASM, and MASM is our assembly language assembler and can only be used in their context. Okay, so if in the Visual Basic, it is like DIM, dim2, and then what? I forgot already. Much of the, I think maybe string. Some of the words that you cannot use when you are declaring any variable or any functions, that word is called as reserved word in any programming language. So the reserved word for the assembly language is, for example, they are different type or category lah. First is the instruction mnemonic. So the instruction mnemonic for the assembly language is such as MOV, ADD, multiply. So MOV will be stand for move, addition, MUL is multiply, and then the reserved word for directive. Okay, so this directive will tell the assembler how assemble programs such as the dot data and then dot code. Okay, so the directive is usually telling, it is like a command, but actually um, it is executed by the assembly. Command meaning it is excluded from executed kan, but for the directive it is like telling the assembler that that segment or that section of code is for data, and then that segment of the code or section of the code is to should be under code punya segment or section. Okay, so after that, attribute. The attribute, the reserved word that is describing about attribute is such as the byte and word. Attribute is more to, for example, the type of your variable. For example, string, integer in higher level language, decimal. Okay, so in assembly language, it is known as attribute. So this attribute is the reserved word that provides size and usage information for variable and operands, such as despite and word lah. After that, there's also reserved word to describe about operator inside assembly language. So operator is used in constant expressions such as uh, 10 multiply 10. So this is like format. Let's say you want to in Visual Studio, you are telling that integer sorry, not integer, dim kan. Wait, I look for Visual Studio punya syntax dulu. Example. Okay. Um, Visual Basic Programming example. I'm looking for this because it is for you to easy to make a comparison between assembly language and then the higher level. Syntax variable. Okay, so for example, this one you said first number equal to 10. And then, if I'm not mistaken, there's a no, there's a how you declare a variable, but also together with its format kan. For example, in when you are declaring a debt, so the operator is some kind of the format of the debt when you are declaring Visual Basic variable. Okay. Okay. Okay, Calvin.
Okay, what?
Okay, so after that, we will use also the reserved word in predefined symbols such as alias data, which return constant integer values at assembly time. So when we want to use any variable that we have already declared previously, so we can just use alias nila. Okay, alias and then the name of your variable. Okay, so after that, reserved word cannot be used as identifier. So what is identifier is anything in your code. For example, the variables, functions, array name, and then any structure or union or label or etc. So all of this word cannot be used when you want to creating all of this. Okay, so this is also about the identifier. So this identifier is actually a programmer choice name. So you cannot choose any name from the reserved word. Okay, so it containing it can be your identifier can be from 1 until 247 character. Okay, so it cannot. I mean, your variable when you are declaring your variable, you can create a variable that up until 247 character. Start from one lah. You cannot have a variable that has no name kan, meaning zero character. So it is start from 1 until 247. If you want to declare a variable that is 248 character, then cannot lah. Ready? Okay, so your variable name can be or your identifier can be including digit, alphabet including digit. It is not case sensitive. Okay, so the first character must be a letter lah. When you are declaring a variable inside the assembly language, the first letter of your variable should be a letter or alphabet. Or this symbol. So you can you can use when you declaring, you can use, this lah. First character must be alphabet, and then you can also use underscore or this symbol, and then subsequent character may also be digit. So any character after that can be digit or any of this lah. But it is compulsory to start with a letter. Okay, so an identifier cannot be the same as assembler reserved word, like I said just now. And then this is the example when you want to create the identifier. Okay. Okay, so after that we proceed to directive. So this is directive is the command that recognize and act upon by the assembler. Okay, so it is not part of the Intel instruction set, and then directive do not execute at runtime, but instructions will be executed at the runtime. So the example of directive is the word. The word, it is in directive. And then the MOV is the instruction. Okay, so directive will be used to declare code, data areas, select memory model, declare procedure, and etc. It is also not a case sensitive. The example of directive here is dot data, so you can write whatever, either it is capital letter ka, small letter ka, it doesn't matter because it is not the case sensitive. Okay, so if in our code, the directive part is the things that are not executed during the assemble punya process is the code that inside this data. Okay, so this is the directive, example of the directive. It is also the example of directive. Okay, so it is macam a marker or a comment, but it is to tell the assembler that this segment is for code, this segment is for data, and then this is the word that used to declare a variable, but it didn't executed during. So whatever code here is the code that will be executed. Whatever the variable that is, or the code from under the data is it didn't get executed um, during the runtime. Okay, so only the instructions yang kena executed. Okay, so the directive, we still in the directive, it is defining the segment, like I just said just now. The segment for the data is identified by dot data. The segment for code is identified by dot code, and then the segment for stack is defined by dot stack. Okay, so one important function of assembler directive is to define program section or segment, like I said just now lah. Okay, the example is the data lah. So the dot data directive identify the area of the program that containing the variable. Okay, so all of your variable that you declared for your program should be under dot data. And then the dot code directive identify the area of the program containing the instruction. So the instruction will be executed during the runtime. Okay, so the stack is the directive that identify the area of a program holding the runtime stack. For example, this one. Okay, so we proceed to the instruction. If previously we know that the instruction is under dot code directive, and then now we learn about the instruction. So an instruction is a statement that become executable when a program is assembled. So when it is said here is assembled, it is actually the same with when your program is compiled. But because it is assembly language, so we call it as assembled. Okay, so it is assembled equal to compiled. Okay, so when you compiled or assembled your assembly language program, you will execute the instruction statement. Okay, instruction are translated by assembler into machine language, into machine language bytes, and then which are loaded and executed by the CPU at the runtime. Okay, so we use the Intel IA32 instruction set. So what is this? This is actually the syntax of how you will write instruction under the dot code directive. Okay, so this is the instruction, the syntax of how you will write instruction. Okay, so first you need to have the levels, but this level is optional, and then you need and compulsory to have mnemonic. After that, um, you need to put the operand. So comment also is optional lah. This operand is usually required. Meaning to say that operands ni it is either it is required or not. It is depends on the mnemonic you will choose later lah. Because some mnemonic require operand, some mnemonics don't. So the example of mnemonic is this one, the MOV, add, sub, multiply. Okay, so that's why the operands is usually required, because some of the mnemonic or instruction mnemonic, it needs operand. So it will make the operand compulsory for some mnemonic. Okay, so for an the instruction contain the label. Okay, wait. Okay, I will make it side by side so you guys can remember the structure of instruction. Okay. Okay. Can see the screen? Isn't it too big? Clear juga?
Can.
Okay.
Oh yeah.
Okay, wait. I will make it bigger sedikit. Okay, so as in the previous slide, this is the syntax of how we will write the instruction under the code directive. So first, it needs a label, which is optional. So this is the label. Okay, so this label act as the place marker. So it's like a marker lah. You need to put, if you need to put some tanda or marker lah. So this label will act as the marker or the penanda. Okay, penanda. Okay, mark the address or offset of the code and data. It is also, this label will also can mark the address of the code or the data that you write for that instruction or for that instruction. Okay, so because this whole syntax is one instruction. Okay, so in instruction, it optionally to have the labels to act as the marker and then to mark the address or offset of the code and the data. Okay, so it follow the identifier rules. All of the rules that we defined for the identifier previously, will be applied for the labels rule. So the identifier rules, remember we have, so this is all the rules for the identifier. So whatever rules in the identifier will be applied to the label punya rules. Okay, so for example, you need to start with a character first. After that, baru followed by the symbol first, and then after that, baru you can put another digit. So all of the identifier rules previously followed by this label. Okay, so there are two types of labels, which is the data label, and then the second is code label. Okay, so for the data label, it must be unique. Example, count. Okay, so this count for the data label, you don't need to put the colon. The colon is the titik bertindih. This one. No need to put the colon. Not this one. Yang ni nah. This one. Yang di bawah dia koma. Atas dia nokta. Okay, that is the colon. So your data label cannot have colon. Okay, so the example of how you write the label inside the instructions is like this. You have this one is data label. Okay, this one is the type of the data, and then this one is the value of the data. Okay, so after that, the second type of label is code label. So the code label, dia punya function is to target of jump and loop instruction. Okay, so if I'm not mistaken, last time we have found these words in our previous lecture, JMP. So JMP is actually stand for jump, meaning it's like go to. If you know go to code, you need, yeah, tahukah go to, GOTO.
Yeah.
Okay, so the jump itu is like similar, more or less similar to the go-to code. Okay, so but when you want to put the code label, you need to put, sorry the colon is the titik bertindih pula, sorry. You need to put this titik bertindih or the colon. I'm confused with the symbol already. Okay, so you when you want to put a code label, you need to put the titik bertindih. So for example, but this example also didn't put the colon. Okay, so it should has a colon here. Okay, after the target. Okay, so after that, we still in the instruction. So remember, this is the instruction. One set of instruction, it's containing mnemonic. So this is compulsory. Okay, so mnemonic here, this is compulsory. So the example is MOV move add sub subtract, MUL is multiply, call is call lah. Okay, so it is act like a memory add. Okay, so memory add is it is like a tool to trigger the information that needed to be executed by the CPU. Okay, so this mnemonic is act like the instruction that need to be executed by the CPU. Okay, so these are the common instruction. This is the common instruction mnemonic that usually be used in assembly language: MOV, add, subtract, multiply, jump, or call. which is call, like you want to call another functions. Okay, so you need to use call. Okay, so after that, this is in your instruction, you need also have operands. So these operands, like I said just now, like I said previously, it is depends on the instructions. Okay, some instruction make the operands is compulsory. Some instruction doesn't need the operands compulsory. Okay, okay, so assembly language instruction can have between 0 and 3 operands, each of which can be a register, memory operand, constant expression, or input-output code. Okay, so your operands, whatever your instruction, meaning this operands is complement the instruction mnemonic. Okay, so whatever mnemonic you choose, it it define or determine the operands after it, after the mnemonic. Okay, so there are, you can have 1 until 3 operands after your mnemonic. Okay, so your operands can be a register name, can be the memory operand. The register name is, for example, this X ini example-nya. This can be a register EAX. You remember we have a register name EAX. After that, your operand also can consisting of a memory operand. So memory operand is like this count, for example, count. And also can be the constant expressions. For example, this one. And then the constant expression is like what I have said previously. It likes a format, the expressions of your variable. So it can be inside or it can be an operand to a mnemonic. Then after that, it can be a constant or immediate value lah. You can, for example, this 60 and 96 or whatever lah, asalkan it is any value lah, the value of whatever you want. Okay, so after that, okay, so this is the example of assembly language instruction having varying numbers of operands. Okay, so like I said just now, the number of operands is depends on the mnemonic or instruction. So there are instruction that have no operand. For example, only STC. STC ini actually only wait somebody calling my name. Sorry guys, there's a JNT guy datang hantar parcel. Wait boleh? Hello?
Oh,
Oh, okay, wait wait Hello. Hi, sorry. Hi. It's post laju ba? Post laju now? Yeah. Post laju is very strict ko. This is, I think, I am rarely got post laju for my parcel. Previously it is JNT, but now post laju kan, they are very strict. Before the postman come, they give us a message, and then that message will provide a number. So when the postman come, they will ask for the number, baru they can give that apa. Maybe it is the enhancement lah for their system. It's good lah because maybe there's the case that another receiver receive the parcel kan. Okay, so we proceed with the instruction. Okay, so this is the example of one of no operand instruction. Okay, so this is just a mnemonic, but we don't know what this instruction means actually. But it is says here it is to set the carry flag. And then for this is the example of one operand instruction. Uh, you if you guys remember that an operand can also be a register or memory. Previously, it is stated in the previous slide. So this is one example of one operand. Okay, so INC. This is the This is the instruction for or to use for incrementing. So INC is stand for increment. So it will instruct. It will increment an operand by one. So it works on a single operand that can be either a register or in memory. Okay, so this is the example of two operand, meaning you can have two operand after this instruction. So example, this your mnemonic is add. So your mnemonic, if it is add, it is compulsory to have two operand because you want to add two value kan. So this is the register punya value, register punya part or segment. This is also register punya part. Okay, so this is actually comment nah. We haven't we will know what comment later in our slide. So this is when you want to comment any code, you just need to put this. I don't know the name of this, maybe the comma semicolon. Okay, so you need just to put this symbol and then followed by your comment lah. Okay, so after that, this is also sub meaning subtract. So for this code says that you need to subtract 25 from the value of my byte. Okay, so from the memory, you need to subtract 25 from the value that is located inside my byte. Okay, so this is also this is to add this value to the value that is located inside EAX register. Okay, so now sekarang baru comments. Okay, so comments, it is optional. For your instruction, it is optional to have comments. You can just didn't put the comment also can, but it is better to have comments lah because it is for people to understand your code. For better programmer, you should always put comment. It is for people to understand your code. And then if you also getting older, and then you don't even know whatever you code previously, then so it is good to have comment lah. Okay, so this comment is optional. Comment can be specified in two ways, or single line or block comment. Okay, so okay. Okay, so the single line comment is you can begin any comment when you comment is only one single line, so you need to put semicolon. Okay, so this symbol is named as semicolon pula. The previous one, the titik bertindih, is called as colon. This one is semicolon. Okay, so when you want to put a multi-line comment, you need to put comment first. So this is the syntax. This is the compulsory part when you want to do the multi-line comment. So you need to put comment first, this word first, but in capital letter, and then follow it with any programmer chosen character. So any character that you put after this comment word, and then you need to when you want to end that comment, then you put the same character that you put after the comment ni lah. Okay, so for example this one, you put any character lah. Okay, so you put this one exclamation marks, if I'm not mistaken, this sign. Okay, so after that, at the end of the line or at the end of your comment, you should also put the same character lah. Okay, so it doesn't matter if you put here the hashtag, then you have to end it with the hashtag too. Okay, so this also accepted, or any, you can use any symbol. Okay. Okay, so for an instruction, there is a case that we need a NOP instruction. NOP instruction is stand for no operation, meaning you can put an instruction that didn't do anything. Okay, so the safest instruction you can write is called NOP, meaning no operation. Okay, so it takes up 1 byte of program storage and doesn't do any work. Okay, so if you put NOP in your instruction letter, if you put NOP in your instruction, that line of code or that instruction will not do any work, but it will take up 1 byte of program storage. Okay, so it is sometimes used by compiler and assembler to align code to even address boundaries. Okay, so this is usually used by our compiler or our assembler, meaning it is used by Microsoft Visual Studio, because example of assembler and compiler is Microsoft Visual Studio. So if you open up this Microsoft Visual Studio kan, you want to see dia punya code, so you will find a lot of knob operations lah, because it is used by the compiler and assembler to align code to even address boundaries. So this is the example of how we will put an OP inside your code. So in the following example, the NOP instruction align the address of third instruction to a double word boundary, even multiple of 4. Okay, so so this is the example lah. The syntax is only maybe you just need to put a label here to tell that your code will be put in this part of memory. Okay, so because NOP will not do any work, it just take up 1 byte of program storage. Okay, so the syntax is, maybe you will put a label lah. It is for you to more understand, because this is optional. It is depends on you. You can put the label or not. but it's better to put lah. Okay, so and then followed by NOP. This NOP is compulsory lah. And then the comment lah. This is also optional. Okay, so that is how you do the NOP. Okay, so this is usage of the NOP. Why people need NOP? Okay, so NOP commonly used for timing purpose. It is to force memory alignment. Maybe you don't want any other in data occupied that part of memory, so you just put NOP there, so that memory or that place inside the memory is occupied by your system or your program. Okay, so it is to prevent the hazard. It is also to occupy a branch delay slot. Okay, so if you want to avoid the branch delay, meaning there's a gap inside your memory. Your memory is segmented kan in few segment, and then you don't want any gap, so you will put that NOP lah. Okay, so to render the void an existing instruction such as jump, and then or as a placeholder to replace by active instructions later on in program development. Okay, so of course this one is not all you can understand. It just so it is enough for you to understand that an OP operation has or doesn't do any work, and it will use 1 byte of program storage. Okay, for the NOP. Okay, Calvin.
Okay.
Farah.
Yeah, okay.
Noel.
Okay.
Okay. Okay, so IA-32 processor are designed to load code and data more quickly from even double word address. So this is just another FYI saja lah. So this is IA-32 processor is this is the type of processor. So processor IA-32 use this syntax of defining instruction. Okay, so this syntax is designed to be like this because it is to load code and data more quickly from the even double word address. So even your address is consisting from, I mean, if even the word, even the address of your data containing double word meaning a word is 16 bit kan or equal to 2 bytes. So when the double byte, I mean on even when your address saja kan, usually address will be specified by only 8 bytes macam a byte macam tu lah, but even your data punya address is containing double word address, your processor or this processor IA-32 processor can also load the code and the data quickly. Okay, so that's why it is designed like this. Okay, so this is the example of assembly code lah. So this assembly code is to add 3 integer. So this is example of adding 3 integer. First, okay, we will learn about this. This title, this include, this code, everything that is written inside this diagram or this picture, we will learn in our next slide. Okay, so this is the example of how we can add three integer using assembly language. So you guys, before that, yeah, Kelvin.
Too small, cannot see.
Oh, too small. Okay, sorry. Okay, can you see now?
Ah.
Okay, so this is actually, sorry, before we proceed to this, Farrell and Kelvin can upgrade your Visual Studio kah?
Haven't upgraded the studio.
Oh, Farrell?
You mean the 2019?
Iya.
Already update.
Oh, can kah? Okay
Yeah.
lah, no problem lah.
No problem, but a bit slower lah for me.
Oh, so it becomes slower lah after you upgrade.
Yeah, like something like if I want to debug kan, it
Hmm?
becomes slower.
So you done the debugging punya exercise lah.
The debugging,
Yeah,
no.
previously the exercise we done previously that you want to check each of the value of the registry.
Yeah, I didn't do.
Oh, you didn't do, okay.
Yeah.
So next week kan, we will after we finish this lecture, we will start the assembly language coding sudah. Okay, so Kelvin, try to upgrade your system before your Visual Studio before next week, kah?
Okay.
Okay. So this is if you remember, this is kind of um the code or program that we added in our previous previous exercise. So this is the example that is included in the program that we have downloaded previously, like this one now. You have two type of program kan we have downloaded when we first download the IRVIN to, and then after that we downloaded this. So the example showed here, which is the add_sub.asm, is this one. It is included in the project that we have downloaded previously. So if you want to run that, this is because I have modify it before when I want to try this code. So it is different from inside the lecture lah. Okay, so it should have something like this. So this code is showing how we can add three three integer. Okay, wait I drink first lah. Okay, so this is the example of when we want to add three integer. First of all, this is the skeleton of assembly language. You can have title. Okay, so whatever after the title, this is the reserved word of assembly language. So it will tell that what is the title of your program. So it will not be executed. So whatever that executed during the runtime is only inside this segment. Under the .code directive, it is the code that will be executed during runtime. So yang after the title ni, you don't need to put comment ke apakah because memang it is reserved word about the title. The title is the reserved word, and then whatever after the title is considered as the name of your program. Okay, so this is also you can put any description about your program by putting this comment lah. So if you want to put more than one multiple more than one line of comment, then you can put the comment in capital letter and whatever symbol, and then after that your comment, and then it is enclosed with the symbol that you choose previously lah. Okay, so this is how you import ka in Visual Basic. It is import ka. If you want to use a library, you use word import ka.
Yeah.
Import. Nah, okay. So include is like import in Visual Basic. So this is the library that usually used by assembly language lah, IR Vine 32. Okay, so this is directive of code. So whatever inside this will be executed. So this is how you will the main not proc lah, procedure. This PROC actually stand for procedure. So this is how you declare or write a function inside the assembly language. It should be start with MAIN and then PROC and then your code. After that, there should be an exit and then you end this process. Meaning, how you end is by putting ENDP at the end of this procedure or function. After that, baru you need to put END main juga because you want to end this main MAIN. Okay, so this is the compulsory punya skeleton of any programming, any assembly language you code letter. Okay, so ayo, I have some of the description I already told you just now. Okay, so the title directive marks the entire line as a comment. So when you put the title, it marks that the entire line here as a comment already. So no need to put any comment punya syntax tu lah. Okay, so the include directive copies the necessary definition and setup informations from the test file. For example, yang this one, this is the example of test file or the library that is located in the assemblers include directory. Okay, so the code directive marks the beginning of the code segment. Okay, so this is marking that all of the code after that will be executed during runtime. Okay, so the PROC directive identifies the beginning of a procedure or function, in the other words. Okay, so MOV, actually MOV saja, tiada MOVE. Okay, so the MOV instructions move or copies the second operand. Second operand is this one. The first operand is EAX, and then the second operand is this value. Okay, so the MOV instructions move or copy the second operand, which is this one, 10000H, to the first operand or destination operator. So these instructions means that you want to move this 10000H to the EAX register.
Miss,
Yes.
the 100H, is it
Mm-hmm.
hexadecimal?
Yeah, hexadecimal.
Oh.
It is a value in hexadecimal. Okay. This is we called as radix. If you remember in previous slide kan ada hexadecimal, ada decimal. Okay, so it is identifying or determine the radix of the constant or constant value of this. Okay, after that, the add instruction. So all of the code after the main procedure, we call that instruction lah. One line, this line is one line of instruction. This line is like one line of instructions. So that is why it said add instruction. So add instruction, add second operand to the first operand. So this add meaning that it add this value, so 40000 hexadecimal to the EAX registry, to the value that is held inside the EAX registry. Okay, so after that, so now if you can see, because this is adding three integers, kan? First, we want to add the value of 1000H to that EAX registry. So now, in the first line, the EAX registry is already have this 1000H punya value. After that, the second line, we add 4000H to that registry again. Okay, so now the value of the EAX is 50000H lah. After that, we want to subtract pula the 2000H from the registry. Okay, then now the value is 3000 hexadecimal. Okay, so subtract is to subtract the second operand from the first operand. So this is actually first operand. Then the call statement calls a procedure. Okay, so this procedure is similar to function. So this call will call the functions which is named as dump reg from this library and then execute it here in this procedure. Okay, so the exit statement calls a predefined MS Windows function. So MS Windows function ni is like it is from the third level language. If you remember just now, the operating system. So it says that assembly language call any procedure or functions from operating system kan. So this is the one of the function from the operating system which is called exit. So it will this statement or exit statement will call the exit statement from MS Windows function, which is the operating system, and then it responsibility is to halt the program. Dia kasih keluar lah from that program. So it is predetermined inside the operating system, which we call the library inside the operating system is MS Windows function. Okay, so the end P directive marks the end of the procedure. So it marks the end of the procedure. After that, the end here, the end directive marks the last line of the program to be assembled. Okay, so it identify the name of the program's startup procedure. Okay, so if you put see here main2 or any name lah, main2 ka apa saja, so you should also end main2 here. Okay, so you should use whatever you want to end. It should be the same as the previous procedure that you have, previous name of the procedure that you want to choose lah. Okay, so the procedure man is the startup procedure. So the procedure man is the startup procedure. So you want the end here is to end the startup procedure. So after that, segments. So this segments is responsible to organize the program. So for example, the segment in this code is the code segment. So this is the code segment. So it organized the program lah. It put all of the executable line under this code segment. Okay, so after that, the data segment, which is identified by data, which is it didn't displayed here, but here in our example, it is written there. So whatever you want to declare any variable, you need to declare it under data segment. Okay, so after that, the stack, which is identified by stack. So this segment hold the procedure parameter and local variable, but it didn't show here lah. The example of stack, because stack usually will be used for the more complex code lah, because our sample is very simple punya code, so we didn't use stack. So only when you want to call parameter, or only when you want to hold a parameter and local variable, then you can put in the stack lah. Okay, so after that, an alternative version of add sub. So this is another example of assembly code, which is to do the add and subtraction. Okay, so this is showing the stack lah. Okay, previously it didn't show the example of stack, and then now it shows the stack punya examples. So if previously it says that stack hold the procedure, parameter, and local variable, so this is it. Any local variable that you want to use throughout your program, you can specify it here. Okay. Macam mana? For example, in your program, in your file, this add sub alt.asm, you have different procedure kan. So this is like the public variable. If you know public variable, it is the variable that can be used by all of the function inside your program. Noel, do you know about the public variable or public constant? Have you used in Visual Studio? I think yes. Visual Basic. Okay, so this stack will hold any variable that is used for the whole procedure that inside the program. Okay, so after that, the directive 3 at 6 is the directive that identify the minimum CPU required for this program. Okay, so in this case, it used the Intel 3 at 6. So this is the version of the CPU that is used. Okay, so for the directive model, .model directive, it instruct the assembler to generate code for a protected mode program, and std call enables the calling of ms Windows function. Std call is one of the function that is defined, predetermined in your operating system. So we just call it saja std call. So this dot model will identify either you want your procedure or your program is protected or public lah. Okay, so if this is more or less similar to the public function and then protected function inside Visual Studio. Kan adakah kamu nampak or have encountered previously public function, protected functions in Visual Basic?
If protected, no lah. I think
Oh, public ada.
public and private.
Yeah,
But-
public and private.
Oh, yeah. So the private is equal to the protected lah. Meaning to say that the code cannot be used by the other program. It is only can be used inside the same program. Okay, so there are two proto-directive. This one, the proto-directive. This proto-directive declare the prototypes for procedure used by this program. Okay, so for example here, the exit process is the function that is from MS Windows function. So it is used, that function is used to halt the current program, or we called as a process. So whatever process that is running, we can stop it. Okay, so the dumb regs here, proto, is a procedure from the IRVIN library that displays the register. Okay, so we are using two functions here from different resources. First, the dump reg is from the library that we have downloaded previously, and then the exit process is the functions from the predetermined functions inside our operating system, which is inside the MS Windows functions library. Okay, so when we want to use any of the functions from that library, so this is the example lah on how we will declare them. So we want to use exit process from MS Windows function, and then we want to use dumreg from the IRVIN32 library. So this is how we declare them. Okay, so last we use them here. So this is how you declare lah. You need to put the name of the procedure first, and then followed by reserved word proto. Okay, so this is the wait. Okay, so we proceed to the invoke. Call. Where is the call? Oh yeah, call already kan? Okay, so now we proceed to the invoke. The invoke reserved word. Okay, so invoke is an assembler directive that calls a procedure or a function. So invoke also, it's more or less similar to the call. So invoke is more or less similar to call. But okay, so this program ends by calling the exit function, passing it a return code of 0. So in this program, you can see that this invoke reserved word, it called the process exit process, and then it passed the 0 to the exit process. Okay, so the function of invoke and call, it is more or less similar. Actually, there's a difference juga lah but it is more technical lah. But what I can say now, you can use invoke if you want to return something lah. But you can just call you just use call if you don't want to add any parameter. Okay, so you use invoke to call a function when you want to give or pass any value to that function, but you can use call when you didn't need to pass any value to that function or to that procedure. Okay?
That's the difference.
Yeah. So that's the difference lah. Actually, there's a big topic behind that too, but it is too technical, so it is enough for you guys to know lah the difference between these two. You can use any of this, either you want to use call or invoke, but the difference is you will use invoke when you want to pass something to that code that you want to call, but you can use call if you don't want to if you don't want to pass any parameter kah apakah, or you don't want to pass any parameter to that function or that procedure. Okay, so this is the example of the template for an assembly language program. So this is like the skeleton lah. So whenever you want to code your programming language, your assembly language, you need to follow this template. You should have title, you should have comment that describe about your program need, and then you need to include, if you want to include any library, and then you also can include any comment here that describe or any symbol definitions, and then you need to include, if you want to declare any data or any variable, you need to include the .data segment. Then if you so this is the most important lah. Usually if you don't want to declare any variable, meaning you don't want to use any constant or variable, then you can, this is optional lah, data. But the most important part is the code. The code is where your line of code is executed. So your code, so this is the skeleton, this is the compulsory. You need to put dot code, and then you need to put main proc, and then you need to put main n proc, and then you need to put n main. So this is tidak boleh lari ah. If you forgot to put any line of this code, then it will trigger error. Okay, so after that, okay, so we proceed to the defining data. Okay, so this is how we can, when you want to declare a variable inside inside the data segment. So this is first we need to know what is the data type lah that we can declare under whenever you want to declare a variable lah. So first is byte or s byte. Okay, so when your data is containing 8-bit unsigned integer, or when your data or your variable containing the 8-bit signed integer, so you can use this this data type. Okay, so sorry. So if you want to use 8-bit unsigned and signed integer, so you use word and s word. Okay, so when you want to use 32-bit unsigned and signed integer, you use d word or sd word. Okay, so if you want to use the q word, so your variable must be in form of 64-bit integer. Okay, so if you want to use t byte, so your variable should be at t-bit integer. So if you want to use real 4, your variable must be 4 byte IEEE short real. So after that, if you want to use real at, your variable must be at byte IEEE long real. And then real 10, if you want to use real 10 punya data type, so your variable should hold at byte IEEE extended real. Okay, so this is how we declare or define our data under the dot data segment too. Okay, so a data definition statement set aside storage in memory for a variable. Okay, so when you do the data, when you declare a data definition statement, it will create a storage in the memory for your variable. Okay, so if that's why you need to declare them first, so that the memory already siap-siap provide that room for that variable, provide a room for that variable. Okay, so may optionally assign a name or label to the data. So this is the syntax of how we can initialize or define our data. Okay, or declare our data. So you can have a label, a name of the label. This is actually optional, but it is good to have because you want to know what you can call this variable kan. So this is actually a name of your variable, but it is optional. So if me, of course I want to put the name of my variable lah. Kalau tidak, macam mana I want to tell you about this kan? About this variable. Takkanlah every time I want to talk about this, or every time every time you want to call this byte 10, you write as byte 10. So it is better if you put a name to your data declaration. Okay, so you need to have name, directive initializer, and this is also optional. Okay, so the example is like this. So this is the name, this is the type of your data, and then this is the value, the initialized value, the initial value of your variable. Okay, so all initializer become binary data in memory. Okay, so all of your data that you put here will become the binary data in memory. Okay, so we are going to proceed to the defining byte and S byte data. So this A character is in type of byte. So you can declare a character like this lah. So you can use byte for a character. So the character you need to put inside the single quote. Okay, value 1, your variable name is value 1, the type of your variable, and then the value of your variable. So this is character constant, example of character constant. Okay, so for the smallest unsigned byte, you can use data type byte, and then this is number kan, so no need the single quote ke apa, so just put the number there. Okay, so for example, the largest unsigned byte, so you also can use byte. But if 256, you cannot use byte sudah, because this is the largest value of unsigned byte. Okay, if you put -1, cannot already, it will cause error already, because the smallest unsigned byte only 0. Okay, so for the S byte, S byte is used for smallest S byte ni is used for sign byte or sign integer. We have learned about the sign and unsigned kan. So the sign, the unsigned ni is the words that doesn't have, if you remember our previous lecture, the sign integer or the sign number is number that don't have negative. It only have positive punya. So that's why it use byte. But for the sign byte, it is the number that have a negative sign. So the smallest, if you want to declare a variable that is a sign number, you can only declare the number, the smallest sign byte you can use as byte is negative 0108. And then the largest sign number that you can declare using S byte ni is positive 127 lah. Okay, so for the byte that you didn't know the initial value, you can just put this apa ni tanda tanya. For I don't know the name in English lah. This tanda tanya lah. If you don't know the initial value of that variable, you can just put tanda tanya here. Okay, so after that, okay kah? Defining the byte and S byte data.
Okay.
Okay. Okay, so after that, we proceed to defining byte array. So this is how you will define or declare a byte array. Okay, so this in this sample we are using multiple initializer. So for example, you have one array and in your array it containing this value. Okay, so this is how you declare an array. You need to put each of the value in your array by using comma. Okay, so if in Visual Basic, if I'm not mistaken, we put something like in the square bracket kan, but in assembly language we didn't use any square bracket here. We just declare it like this. So this means that your variable list1 is an array, and then you are in each of the array is containing only a byte, small punya number lah, which is still in byte lah. Okay, so when you declare it like this, so in the memory it will be stored like this. Okay, so this is the offset. The offset is the index of your memory, because your memory is divided by small segment or small room kan. So this is the name or predetermined name of each of the segment inside your memory. Okay, so if you declare an array, it will use up until the size of your array lah. So if your array is 1, 2, 3, 4, then your memory segment that is used in the memory is also 4. And then each of your array will be stored by different segment lah. So each of your array will contain its own address. Okay, so this is the example of how you will declare another array lah. First ni, and then byte ni. So this is the example of you didn't put any name to your the variable. Okay, so this is also how you can declare a different type of data type inside one array. So you can put either you don't know whatever it is, and then you can mix hexadecimal, decimal, and binary in one array. So the same with the example list 4 lah. Okay, so now we are this is how we will define a string in assembly language. So a string is implemented as an array of character. Okay, so when we store the string or when we first declare the string, it will be the memory or the computer will make each of the character inside your string to have its own segment inside the memory. Okay, so that's why that is what it means by this statement. A string is implemented as an array of character. So for convenience, it is usually enclosed in quotation marks. So it is often will be null terminated. So it often will be null terminated. String of this type are used in C, C++, and Java programs. Okay, so the example is how you declare a string is this one lah. So usually you will put 0 here because it is null terminated. Meaning if there is it will be terminated when there are no more character found inside your string. Okay, so it is so it is compulsory to have this lah 0 in this one null terminated ni. Okay, so you can declare your string like this, enter your name. You can also meaning using double quote. You can also declare your string using single quote, and then you can put any a symbol inside your string. It doesn't matter. And then you can also declare your string like this, meaning each one of your string is this is considered as one string lah. Okay, after that you can also declare it like this without the comma or and the 0 here. Okay, so after that we proceed to Astaghfirullahaladzim. Guys, our class should be ends on 1:30 kan?
Oh yeah.
Sorry. I use your time for 10 minutes already or 11 minutes. So it's okay lah. We we continue our lecture. We ends in here defining string, and then we will continue until the 101 in next week. After that we will start our assembly language program lah. Huh? Okay, sorry. Next time you just remind me lah if I forgot sudah. If I terlimpas sudah.
Okay, Miss.
Oh, okay.
So you guys have class kah after this 2 p.m. Ada kan?
Yeah, got.
Oh, sorry. Okay, bye.
Okay,
Okay,
thank you.
Miss. Thank you.
Okay, bye.